Let's talk a little bit more about the moon's appearance and structure. Um, One of the other things Apollo astronauts did on the surface of the moon is they actually left seismic, I'm not going to try and spell seismic today, seismic equipment, so that they could detect moonquakes. And that was done so that we could learn about what the interior of the moon actually was like. Until we could actually get up to the moon, we didn't have a lot of information about what the interior looked like. Now we have more modern equipment so that we can detect a lot about the interiors of some of our neighboring planets. But back in the 1960s, we actually had to get up there before we could do that. What we found was the moon, just like the Earth, parfaited itself out into layers when it was hot and when it was molten. There is an inner core, and the inner core, part of it is liquid. And there is a very, very weak magnetic field around our moon, but not very much at all, because of the fact that it has a very small quantity of iron and nickel in it. Now, one of the most striking features of the moon is the fact that it has light spots and dark areas. Back in Galileo's time and before that, Earthlings would look up at the moon and thought that the large dark areas were actually seas. They thought they were oceans full of water. The Latin word for sea is mare or Maria. Okay, repeat that, because this is not Maria, like a girl's name. This is Maria and Mare. These are actually remnants of old lava flows, and these are flat plains. These are vast areas where lava has spewed to the top of the moon and then spread out, sort of like if you spill milk on the kitchen counter, it's going to kind of smear out into a flat puddle. Now, how did these mare or Maria get created? This is the hypothesis. If you look at the actual crust of the crust of the moon is not as thick as the crust of the Earth. And there are some really, really, really large, huge mare across the surface of the moon. What we believe happened was during areas or periods of time of lots of asteroid bombardment, big asteroids would come in, impact the crust of the moon, and this would cause the subterranean rock layers to crack. And what oozed up through these cracks? Well, lava from the hot, molten interior of the moon oozed up through these cracks, filled in all of these low areas, and when these low areas got filled in with hot, flowy magma, you ended up with these large, flat plains, and those are the mare. Now, here's something that's really interesting. When Apollo astronauts and probes first circled the moon, the front of the moon had lots and lots of mare and looked like this. Each one of these blue areas is a mare. If you go to the back side of the moon, very few mare. Well, how the heck do you get a planet where one side looks very, very different than the other side? We'll get there. One of the other things we've discovered when we look at the moon is we actually look at craters. If you want to go back in history and say what kind of craters hit when, you look at which craters are within other craters. If you look at this area right here, you can see there was a large asteroid bombardment, some sort of meteorite hit, and then there was a slightly smaller one, and then there was a slightly smaller one, and then there was a slightly smaller one. This is one of the ways astronomers can back the movie up and determine what was the history of an asteroid or planet or moon. And by looking, we can determine that at one point in history, there was a lot of big rocks that were colliding into things. And through time, these rocks got smaller and smaller and smaller. There's a line that separates the day from the night, and it's called the Terminator. When astronomers are looking up at the moon and they're trying to determine how high the mountains are on the moon, they look at the Terminator. For a long time, back in the times of Aristotle, it was thought that the moon was perfectly smooth, and it was the purpose of the moon was to reflect the light of the sun down on the earth for the use of man. That was the hypothesized reason the moon existed. Remember, many thousand years ago, we were very egocentric. But with the invention of telescopes and Galileo, he actually started looking at the Terminator. And what you can see when you look at that line between the dark and the light is you can see things like this right here. There is actually a light area in that crater and then a shadow in that crater. That is an indicator that this crater actually has some height. There is some depth or height to it. And it was the first proof that the moon is not flat and smooth. It actually has dimension. This is another beautiful close-up picture. The light, obviously, from the sun is coming from this direction, causing shadows on the right-hand side, and the interior walls of this crater are all nice and bright and lit up. It really helps. At that Terminator is where we can really study the three-dimensional surface of a moon or a planet. When we look at the moon itself, there are many unique features, and I think one of those that I'd like to have you know is the Sea of Tranquility. Now, Sea of Tranquility is the English name. Mare Tranquillitatis is the Latin name. Mare, because it's sea, and then tranquility is Tranquillitatis. And this was chosen as the Apollo 11 landing site. As you can imagine, the very first time we decided to land something on the moon, we wanted to give it a really big target to hit, and an area that would be flat, free of a lot of craters, and free of a lot of debris. So we wanted to have the astronauts land someplace where they weren't going to be injured or crash their spaceship the first time down. And this is the Sea of Tranquility. And I had to throw in the Terminator. I'll be back because, yeah. Okay, so let's go back to this mystery. Why is the front and the back of the moon look so very, very different? This is a photo of the front of the moon, and this is the photo of the back of the moon. And the front, of course, has all of these lovely mare or maria, and the back, heavily cratered, very few areas where this molten lava has come out and spread out. What the heck? What's going on here? The big hypothesis of what's going on is that the front side and the back side do not have the same thickness. It is believed that the front side of the moon, the crust is actually thinner. And the back side of the moon, the crust is actually much, much, much thicker. Now, both the front and the back side of the moon are heavily cratered, lots of bombardment from asteroids and meteorites, but because the front side was so much thinner that when something would impact and it would crack the underlying layers of the moon, it would get down to the molten areas and it would allow that magma to flow up and spread out and create those mare. On the back side of the moon, because the crust is so much thicker, an asteroid would bombard, and it would not actually crack far enough down to get into the molten part of the substrata. So how do you explain that one side of the moon is thicker than another? Well, here is a hypothesis that a lot of people believed for a long time. This hypothesis is not in favor at the moment, but for many years it was believed that the moon had a little sister, and this little sister was orbiting just a smidge faster than the moon itself, and kind of in slow motion, that the little sister of the moon ran into the backside of the moon and made the moon a little bit fatter on the backside, thicker in its crust, because it had a little small moon that actually smeared itself on the backside of the moon. For many, many, many years, and back in the days when I was in college, this is what I was actually taught as the best hypothesis of why the moon is not the same thickness front and back. But in the last couple of years, this hypothesis has been thrown out in favor of this one. And remember, these are hypotheses. We don't know for sure, but we're looking at what is the most probable and which one has the best evidence for it. So the best evidence that we have for the different thickness of the crust is something that is called uneven heating. And it goes like this. Early in the formation of the Earth and the moon, because it was so much smaller, cooled long before the Earth did. This tidal locking, so that there was a front side of the moon that faced the Earth and the back side of the moon that was always away from the Earth, computer modeling shows that that could have happened in as quickly as 100 days. Very, very speedy when you start talking about anything in astronomy. Also, when the moon was first formed, it was 10 to 20 times closer than it was now. So what that meant is the front side of the moon was facing this hot, molten Earth. This hot, molten Earth was baking the front side of the moon. And because it was already tidally locked, the back side was cold and the front side was very, very hot. And it was believed that the heat from the moon caused material that could vaporize to vaporize off of the moon, and then a certain amount of atmosphere thrown off by the Earth and some rotational inertia would cause this material to move to the back side of the moon where it would cool. And this created this extra thick crust. Primarily that the moon has a skinny side and a fat side due to this uneven heating and cooling. Now, this concept of vaporizing and deposition you see every day. When you get water very, very hot, it creates water vapor. And when water vapor hits something very, very cold, like a cold window frame, it solidifies back into something that is solid. And so this is a common example of vaporization and deposition that we believe occurred on our moon. Nice little video from the Jet Propulsion Laboratory of the evolution of the moon. This one has no audio, but I'd like to have you give it a shot. All right, that will do for this time. We'll see you later. Bye.